What? You were saying you did 25 instead?
Yeah.
That's fine. That's totally fine. If we did 25, though, let's do that as practice just for this section if there's no other questions here. Is it telling you that it is an infinite geometric series on 25? I think it says it is, right? So that's kind of nice. Like, take what you can get, right? So if you're finding the sum of an infinite geometric series, what do you need to find first? First term, yeah, A and R. So A in this is 80. What's R going to be?
1 over root 2.
So the sum is just going to be 80 over what? 1 minus root 2. Is that correct?
Mm-hmm.
Now, what's the problem with that?
Because it's, you got the 1.
The square root of 2 is what?
Greater than 1.
Greater than 1. Therefore what?
It's divergent.
Divergent. I mean, the way that should logically scream at you is if you actually do this here, this thing is negative, right? And the sum of a whole lot of positive numbers should still be positive. So if you see something like that, it should key in, oh, wait, there's this. Has everybody seen these 3 dots before, by the way?
Yeah.
That means therefore. There are maybe 15 to 20 super common math words that have symbols for them instead. Like for all, and that means for all. This means there exists. This means factorial and unique. This means contained in. So you'll see that. Yes, question?
Is it 1 over root 2r though, less than 1?
Yeah.
Oh, I'm sorry. I totally wrote it wrong. You're absolutely correct. Good catch there. So if it was root 2, I'm sorry, if it was root 2, that would make sense. I wrote it not properly. It is actually 1 over root 2, so that is okay. Now on this one, I'd be okay with that being the final answer. That being said, are you capable of simplifying that a little bit? On an AP test, will they? Yeah. What will they do to that? That's 80 over 1 minus root 2 over 2, right? Which is the same thing as 2 over 2 minus that. Is that correct? I think so. So it's 80 over 2 minus root 2 over 2. So that's 80 times what? 1 over what? 2 minus root 2. So then you have 80 over 2 minus root 2. Oh, wait. We just kind of, oh man, we just went in a circle. If you wanted to rationalize this, what would you multiply by? Does anybody know?
2 plus 2.
Yeah, then you take this and you multiply by 2 plus root 2 over what? Why do you do that? What happens if you do that? You get 16 plus 8 root 2, but what happens on the bottom? What do you end up with? 4 minus what? 4 minus 2. So you end up with what? 8 plus 4 root 2. So that's what you would see probably in the answer book. I'm okay with it leaving it right there. Okay, so the only questions that left are down towards the end of the questions. Okay, Wiley, which one is it? Hit me. I'm a little scared right now. Should I be a little scared?
No.
No?
31.
Is it this one right here?
Yeah.
Oh, good. Okay. We can totally do that one, sure.
I'm unsure on like kind of what they were asking me to do.
I understand. Totally fine. Okay, so on 31, if we do this one right here, it says, find the sum of the series. For what values of the variables does the series converge? Okay, so is this a geometric series? Let's say if it is, A is going to be 4, and what's R going to be? What's R going to be?
Well, R should be y over 3, but it doesn't work.
Well, could you...
Hold on. I love the harmony. I understand what you're saying. Could you start it somewhere else and just have 4 at the end? Yeah, so this whole thing could be viewed as 4 plus this thing, right? Do you agree?
Yeah.
So if you're just looking at this right here, what's the A value? I like this. A is what? Y, and what's R? Y over 3. So this is a geometric series. So if we want to have the sum is going to be 4 plus, what's the first term? Y over what? Y over 3. We know that this will converge if what is true? If the absolute value of R is less than 1, right? But what is R in this case? So the absolute value of y over 3 needs to be less than 1 for this to converge. Can we solve that? Yes, we can get a range. We can get a range. We can, right? So what does that mean? It means y minus 3 has to be less than 1 or greater than So negative 3 like this. How do you read that out loud, by the way? Can someone read that out loud for me? Read that out loud. What does that say?
Y is negative 3 less.
Both are good. I like that one a little bit more. The thing is, don't read it from the left. Neither of you did, which is what I was looking for, but you'd say y is greater than negative 3 and less than 3. So if y is between those two values, it will converge like that. Depending on what y is, it might change though. Chip and then any.
I did it differently.
Did you get the same answer?
Pretty much.
How did you do it?
Instead of using y as the first term, I made it 3 the first term and just did +1.
Oh, sure. I mean, the thing is, it's not asking you for what the sum is, right? It's just saying, will the series converge? Like 4 converges, so we can kind of ignore this, right? If we wanted to, because you can cut off any finite number of things. If a series, here's something to think about, everybody. Here's a series, everybody. It's infinite, okay? Keeps going. It either converges or diverges. Do you agree that series either converges or diverges? Do you agree with that? If I chop off a finite number of terms, 7 terms, 10 terms, a billion terms, does that change anything about divergence or convergence? What do you think? No. If it converges or diverges, I can take away a finite number and it'll still diverge or converge. Think about it. If something is infinitely big and you take away a finite sum, is that going to change the infinite nature of it? No. And if something is finite and you make it smaller, what is it still? Finite, or bigger if it's negative. Do you understand what I'm saying? Like finite plus finite is finite. Infinite minus finite is infinite still. That's what I'm trying to get at. Okay, any other ones from the homework? Yeah. Yes. Oh, sorry.
So a geometric series doesn't have to have the successive terms having one ratio then, because
well, no, hold on. So this is not a geometric series.
Okay.
This is a geometric series. So the whole thing is a geometric series plus 4. This is just tweaking it just a little bit. Because look what it's asking. It says, find the sum of the series. Does it say it's geometric? Up here. Sorry, up at the top. Do you see geometric anywhere in this first line?
No.
It just says series. Yes, the whole thing is not geometric. Most of it is, though. Yes, Ian.
If we were given this type of problem,
Yep.
only instead the 4 was like in the middle, and then we didn't have like.
That's me being a jerk.
Yeah.
That's me being a jerk. There's a lot of jerk things I could do to tests, you know? Like when you're in Algebra 2, it's like, if everything's already in order, factoring is easier, right? So what could I do? I could put the terms out of order, right? Make the fractions not pretty, you know? Like instead of writing 5, I just write e to the pi I plus 1 plus 7. You know, there's ways that would be nasty. Generally, no. Generally, no. I don't like it because if you were not to notice that, you just couldn't do the problem. You'd be like, this is not geometric. But like, it's only one word up here that changes that right there. Okay, are there any other question we did in class?
Yes.
The drug dosage one, right? The drug dosage one was 250 milligrams and like 4% remains. This is the exact same thing, except it's 8 tons and 25% is removed by natural processes, right? So think about it this way. The last amount of tonnage is going to be 8 tons, right? After the last dump on it, right? The second to last is going to be what remains after 1 day times what? What do I multiply 8 by for what remains? 3/4, exactly. So 3/4, right? What's the 1 2 before? It's going to be 8 times what? 3/4 squared. So if you go back on this, right, what do you end up with? 8 times 3/4 to the n minus 2 and 8 times 3/4 to the what? N minus 1. So this is the total pollutants. The total pollutants right there. Is that a geometric series? Yes. So they're basically asking, if this went on till the end of time, what's the maximum amount of pollutants that could be in there, right? The maximum amount of pollutants that could be in there. What do you do here? What's the A value? What's the R value? What's the R value? 3/4, 0.75. In this case, and again, it's not written in the proper way, but this is how we wrote it first. What's the A value? 8. It gets smaller, right? So what's the sum going to be? 8 over what? 3/4. So it's 8 over a quarter, so it's what? 32. So it means as you add the pollutants in, can you ever get to 32? Are you ever going to have more than 32 tons of this stuff in there? No. You're going to get infinitely close to it though, right? Because what you're going to do is, in a billion years, what's going to be happening, right? You're going to have like just under 24, like around 24 tons in there, and then you're going to add 8, right? And then it's going to jump up almost to 32, and then what's going to happen? The total degradation will bring it back down to 24, and it's going to keep on jumping up close to 32. Will it ever get to 32? No, it will not. Okay, is everything put away except a pencil? Is it? Is it? It's like easy to write down, doesn't mean it's easy to see. So what was it? 1, 2, 3 over 2, 5 over 3, 8 over 5, and 13 over 8. Anybody notice anything key about this one? What's one thing you immediately notice, maybe? Yeah, what's one thing you notice, Ian?
I forgot what it's called, but it's that series. Only one of them is like one spot ahead of the other on top of that. Fibonacci, yeah. So
oh, you saw Fibonacci?
That's what I did.
Totally not what I meant it to be. Sorry, that's a red herring. That's a nasty red herring too. No. Look, but look. What do you see? What did I highlight there? Oh, that's just the wrong. Hold on. It actually. Did you notice when you highlight two colors, it makes the actual real color for mixing them, which is pretty cool. So look, what do you see? 2s, then 3s, then 5s, then 8s. So yeah, but do you see how they're? The important thing is they're linked. But what happens? Where does the 2 go? It goes from numerator to denominator. How do you flip a fraction over? How do you flip a fraction over? You make it the reciprocal, right? What operation? It's 1 divided by a number flips it over, right? So what's the flip of 2? 1/2. What's the flip of 3 halves? What's the reciprocal here? What's the reciprocal here? 5/8. What's the relationship, everybody? What's the relationship, everybody, between this and this? What's the relationship? How do you get from there to there? Plus what?
1.
Plus 1. What do you do from here to here? What? Plus 1. What do you do from here to here? And what about from here to here?
Oh, it's so simple.
Well, but that does not mean it's easy to see. I wanted to throw that out there just to kind of push you a little bit. So the formula for this one is, what do? You take 1 and you divide it by which term? Which term? The Sn minus 1, right? And then what do? That's why I'm dividing by 1. It's to the negative 1, yes. And then plus what? Plus what? 1.
So wait, is this arithmetic?
Is it arithmetic? No, it's not arithmetic. It's arithmetic if you look at the reciprocals. But no, arithmetic would mean a constant difference between the terms. There is not a constant difference between the terms. The difference between 3/2 and 5/3 is not the same thing as this to this. It's constant once you reciprocate it, right? This is not easy. This is not easy. This is not easy. But I wanted to throw you out one that was really fun. How many of these quizzes you're going to get?
A lot.
Let's chat about them for a second. You get a lot of them. The one thing I allow you to do on these is to make corrections on these right here, and you can get up to half. So let's move on to something fun. Yay! So we did sequences of partial sums. So do you remember we had a sequence 1, comma, 1/2, comma, 1/4, comma, an 1/8. Partial sums was any sum of anything other than all of them, right? So like if you had a sequence 1, then a 1/2, then a 1/4, then an 1/8, the first partial sum is 1. What's the second partial sum? 1 1/2, because you add 1 plus a 1/2. And then how do you get the next partial sum? Add the next one. And you want to see, does that converge? And that would be finding out if it, like we did geometric convergence. Yes, Chip.
I just thought of this.
Yep. So on these, we're looking to see if the partial sums converge. So this is what we're going to do here. We need to learn about which things converge. And we already know a little bit about it. What's the one little thing we know already? How can we tell if geometric series converge or not?
Absolute value of R is less.
Right. So, for example, this one right here. Let's see if this one converges. If n is 1, what's the first term on this one? If n is 1. 1 minus what? Yeah, 1 over e, right? What's n equals 2? What's the second term? 1 minus what? Yeah, and we see the pattern here. So these are all the terms. Is this geometric? Does the series converge? Does the series converge? So this is the first term, this is the second term, this is the third term. What do you think? Does this converge if you add up all those pieces?
No.
Logically, can someone explain logically why it doesn't? Yeah, Nam.
It's like it will, like each term will converge to 1.
Yes, the terms the terms converge to 1. So if they converge to 1, if n gets huge, what are you going to be looking at? 1 plus 1 plus 1 plus 1. Does that converge? No. So for something to have the chance of being convergent, for a series to be possible for it to be convergent, what's the first thing you check? Do the terms go to 0? Do these terms go to 0? They go to 1. So does this converge? No. Let's say they went to 0. Does that mean the series has to converge? No. What was the example I gave you last class? There's a really classic series.
The 1/2.
What's this called? Anybody know? Harmonic, right. This one right here, I just get to tell you right now, and it's on your homework tonight to prove this. The harmonic series, this right here, is divergent. Do the terms go to 0? Does the sequence of terms go to 0? Yeah. Can you get infinitely close to 0? Do they keep on getting smaller? Yes. But does this converge? No. You'll prove this tonight, okay? You'll prove this tonight?
Is this the only one?
No, there are many, many. But this is a really important one. We're going to use it a lot. We're going to use it a lot because of this right here. If I can actually scroll to it right here. By comparison. Okay. Let's say we knew how tall I was. I'm 5'11", okay? 5'11". Let's say all we know is that Ian is taller than me. How tall do we know he is at least? He's at least what? 5'11", right? Well, let's say we knew Ian was shorter than me. He's at most what? 5'11". So let's say we had a series that we know diverges, that blows up, okay? Let's say every term of another series is above those terms. What do we know about the new series? If you're above something that blows up, what happens? It also blows up. So we know the harmonic series gets really big, right? Without bound. What happens if I had another series where every element was bigger than the harmonic series? What do we know about the new one? It would diverge too. If you're above something that blows up, what happens? It blows up. What about 1 plus a half plus a fourth plus 1 plus a half plus a fourth plus an eighth plus a 16th? Does that converge? Yes. Converges to what? Do you remember? 2. Let's say every term was below that. What would you know about the new one? Converges. Above diverge, diverge. Below converge means converge. Those are the only definitives. You see what I mean? If you're stuck in a room, you're stuck in the room. If you're stuck outside the room, you're outside the room. Now, those are the only 2 cases that tell you something definitive. What happens if you're below a divergent? What does that tell you? Nothing, right? If you have something that's infinitely big, and I say, well, you have something smaller than that, guess what? It can still blow up or diverge, right? And then the opposite of that is true. Let's say you were above a convergent. Does that tell you anything? No. Just because you're above a convergent doesn't mean it also converges or might diverge. So what does that mean? Look at what it says right here. It says, by comparison, by comparison with the improper integral, show that the following series converges. So take a look at this thing right here. Take a look at this. It says 1 plus a fourth plus a ninth. 1 plus a fourth plus a ninth. Could you list out some more terms for me?
Plus 1/16.
Yeah, what's it going to be next? 1/16th, then what? 1/25th, right? What was the harmonic series? It was this, right? Correct?
Yeah.
Let's put each of them, here's the harmonic, right? And what's this one? 1 and then what? Plus what? 1/16th, right? So you know this. You know, I'm writing it out mathematically in mathematic proper language, even though I can't say it at the moment. The sum of n goes from 1 to infinity of 1 over n squared. We know that that's going to be less than the sum from n to infinity of 1 over n. And we know that this right here is what? So, wait a minute. It's divergent. So what did I just say here? So if this is less than a divergent, do we know anything conclusively right now? No. So this doesn't help, but it is true. So let's find something else to compare it to. I try to do this sometimes because are you always going to try the right thing first? No, you're not going to try the right things first. You're not going to try the right things first. So if we want to compare this, if we want to show that it converges, we'd like to find something it's less than. Use a different one. 1 plus a half plus what? Plus 1/16, right? And so that's the one we know converges, right? We good? So what's this next one? 1 plus a fourth plus what? 1/9 plus 1/16. So what do we know? We definitely know that the sum n equals 1 to infinity of 1 over n squared is going to be less than the sum n equals 1 to infinity of what? 1 over 2 to the what? N. And what does that do? So because that converges and all those terms are less than, what do we know about this one? It converges. Do we know what the sum is? We don't know what the sum is. Is that a geometric series? Is this geometric? No. Is it a constant ratio? No. So we know it converges, but we've yet to be able to figure out what it converges to. That's fine. Okay. So let's take a look at this. So this is another way to look at it right here. It's another way to look at it graphically. Evaluating improper integrals. We're going to cover it again tomorrow as a review, so if you don't, that's okay. But do you know how to evaluate integrals? Are you okay with that? Why is that an improper integral right there? What's it going to? No. What's no, I like what you're thinking there. No, not with how it's written. It's going to what? Infinity. This makes it an improper integral because can you plug in infinity into something? No. So the way you write this is the limit as x goes to infinity, as, not x, pick anything other than x, b, as b goes to infinity of this.
Why can't you pick that?
Because x is already in there. You need an index that's not x because it's not x. So here's the thing. We're not going to evaluate this right now, but let's say we did some magic on this and we got the number 8. I'm just making that up, everybody. That is made up. That is totally made up. But here's the thing. What's the area of this rectangle right here? 1/4. What's the area of this one? 1/9. What's the area of this one? 1/16. See these numbers here? Remember, we know it converges because we compared it to something that converged and it was less than it. But here's the thing. If we add up all these rectangles, what's bigger? The actual area under the curve or the sum of all those rectangles? What's bigger? The actual area. So let's say we calculated the actual area with the improper integral and got 8. Is that a convergent number? It exists. It's not infinity. It's not infinity, right? It's 8. So we know that all of these add up to something less than 8. So does it converge?
Yes.
Yes. So if you can find an integral that you can evaluate that comes out to a static number that is always above those rectangles, you can prove that this is convergent. Now here's the thing. You might not remember how to do this, so we'll do it. That's going to be what we're going to be covering. But do you understand the basic idea here? If you're above something that blows up, what happens? If it's below something that's convergent, what happens? So you need to have like a lexicon. You need to remember things like, for example, the harmonic series is
Harmonic.
It diverges, right? So you're going to use that sometimes. You're going to use that. You are going to use that. Okay. So here we go. Okay, integral test. Here we go. So let's see here. This is what it says. If you integrate the pieces, essentially, if you integrate the pieces, if the integral converges, then the series converges. So what was the strict definition of this one right here? Do you remember what the definition of this one is? This one was the integral of n equals 1 to infinity of what? 1 over
x squared.
Yeah, x squared right there. If the integral, if that converges, then this converges. You with me so far? But then what does the other one say right here? It says, if it diverges, then the integral diverges. So it's pretty cool. So you just need to actually integrate the explicit formula. You might like integration. I like it. It's pretty fun. So let's take a look at this one right here. This is an important piece. P greater than what?
1.
Yes, that is correct. So you get to take that as truth. Whenever you see something where it's 1 over... P is a constant. This is a constant.
And it's an integer?
Yeah, no, it doesn't have to be actually. But I just,
About like 1.1.
that's fine. It's steep. So what about it? What do you think?
You don't know.
Well, we think based on our analysis right now that if P is greater than 1, then it converges. So based on as b goes to infinity of 1b x to the negative 2 dx. What's the integral of x to the negative 2?
Negative 2x.
Not the derivative, the antiderivative. Negative x to the what?
Negative 1.
Negative 1. Right there. And you're doing that from 1 to b, the limit as b goes to infinity. So what do you do here? It is the limit as b goes to infinity of what?
Negative x to the b.
Not x. The x gets replaced with b to the negative 1, right? Minus
Negative 1.
negative, you have to be really careful about this, negative 1 to the, are you with me so far?
Yeah.
Is everybody with me so far? There's a lot of negatives in there. A lot of negatives. So what does this mean? It means the limit as b goes to infinity of what? Negative 1 over b plus 1. What does this go to? If b goes to infinity, what does that go to?
0.
0. So what's left? 1. So we just showed right here that this whole area right here, what does it add up to?
1.
That is 1. If you add up all those rectangles, this right-hand Riemann sum, this right-hand sum is going to be less than 1. So therefore, does this converge? It does converge. It does converge. That's how you do it. You'll practice this. You'll practice this. You just can't plug infinity into things. It's kind of the same thing, but not really. Infinity is not a number. It's not a number. Okay, everybody stand up. Everybody stand up. Let's just go to the fun stuff. Find a piece of the board with somebody you're not sitting next to right now and work on these 4 problems. What does it say for the integral test? What integral am I going to evaluate to see if this converges? The integral of what? 1 to 1 over x cubed dx. What are you going to evaluate here? 1 to infinity of? So can you see what you're trying to do here? So if this converges, what does it tell you about this? It converges. If this converges, that converges, or vice versa. If it diverges, what does it say about the other one? It diverges. Yep, that's this. The most important thing you just got, well, besides the P series, the most important thing you got is this, right there. Convergence of the integral implies the convergence of the series, and divergence of the integral implies divergence of the series. Just going to check one more thing. Don't pack